after the vacation.
Okay, after the vacation. Then here also after this chapter we can start Euclid's geometry, right? Yes. Yes. So yeah, why not? Let's start the same chapter, Euclid's geometry. After this class we'll be starting.
Okay.
This is D. Don't see this sign and all. Don't get confused. Okay. This is B. This is C. This is A. Here we are having this figure. Okay. M is the point of intersection. And in the right triangle ABC, right angle at C. So it is given in the question. I am writing the given part over here. And that space will be using for proving it. So it is given over here that angle ACB is 90 degree. This complete angle, it is 90 degree already given in the question. I am not writing, it's given in the question itself. Okay. Now M is the midpoint of hypotenuse AB. M is the midpoint of hypotenuse AB is given in the question. Okay.
Yes, ma'am.
It is given that M is the midpoint of this hypotenuse A. C is joined to M and reduced to D such that it is also given that DM is equals to CM.
Yes, ma'am.
Okay. Now we have to show that one of the part which we have to show is triangle AMC is congruent with triangle BMD. Next one is angle DBC is a right angle. Okay. And third and fourth part is also there, which I am writing over here. Third part, which is given in the question, is okay. Let's focus on first and second part first. It is given in the question that we have to show that triangle AMC, okay, triangle AMC and triangle BMD. This is your. Why does equal?
Ma'am, I think
Am I
somebody
on?
joined 2 times.
Ifra?
Yes, ma'am.
It is echoing. See, whatever I am saying, it's echoing. Have you joined? Okay, now
Is it fine now?
Yeah, it's fine. Everyone can hear me?
Yes, ma'am, we can.
Yes.
So let's finish it. So we have to prove that triangle AMC, this triangle AMC, this pink color triangle, and triangle BMD, the other pink color triangle, these two are congruent. Okay. However, the information is straightforward. It is given to us that AM is equals to PM, DM is equals to CM. See, one of the side, if we are talking about triangle AMC and triangle BMD, it is clearly given in the question that AM side from here is equals to BM side from there. Given already. I have written also. Okay. And apart from that, it is also given that CM side from here is equals to DM side from there. It is also given already. Okay. Now we realize in the previous class what is the angle which is same over here. Which angle is same? Who will say? Apart from this two information, what is the next information which we can use over here?
Ma'am, can I
Observe. Yeah, please, Tejas.
Angle CMA is equal to angle DMB by vertically opposite angles.
Angle CMA is equals to angle DMB. This two, this one and this one are nothing but vertically opposite angle. And hence triangle AMC and triangle BMD are congruent with each other. By which congruency criteria?
Yes.
By side angle side. See, if you will mark it in the figure, this is side this angle and this side. Okay, side angle, side congruency criteria we have used by SAS congruency criteria. Okay, what is the next part which we have to show? We have to show that angle DBC is right angle. DBC, it's a right angle. That's what we have to show over here. Where is DBC? Let me mark it. Here, this angle, this complete angle, we have to show that it is right angle. Okay. We already know that this is 90 degree, but we don't know what is DBC. How we'll be doing it? Since these two triangles are congruent with each other, there is a corresponding angle. Okay, we can say from the name of the triangle, angle A over here is equals to angle B over here. Yes or no?
Yes, ma'am, we can say.
We can say, okay. Astitwa, are you getting it?
Yes, ma'am. I can understand. Yeah, I can understand.
Okay, angle A over here is equals to angle B over there. Angle M over here is equals to angle M over there. Angle
Yes,
C
ma'am.
over here is equals to angle D over there. Any information we can use over. Any means angle A and B we can take, or maybe C and D we can take.
Ma'am, all interior angles are parallel to AC and DB.
Exactly. Okay. So let me mark angle A and angle B, which we are talking about one of the angle from this triangle, angle A. Angle A. Is equals to angle, this two part of congruent triangle. Okay. Anyone who has unmuted? Okay. These two are corresponding part of the congruent triangle. Now we'll be saying that there is a line here, we can write it. We know that angle A from here is equals to angle B from there. But we will be writing the proper name of A. That means we can write, just a second, automatically it got closed. Okay, so we will be writing from here that angle A from here is equals to angle B from there, but a proper name of the angle we must write every time. So angle MAC is equals to angle, what will be the name of angle B? Who will say? Who will say?
Will be
Can you see my
MBD.
MDV.
Yeah, MBD. Okay, angle A from here is equals to angle B from here, and the name of that is A. We will be writing in the middle. M and C here and there, one on the left, another on the right. We can write it. Okay, angle B we want to represent, that we will be writing in the middle, and the remaining M and D from the triangle, these two vertices, will be one on the left, another on the right. This is how we write it. Astitwa. Even without looking at the triangle, we will be able to mention the proper name of the angle. Okay. Now these two angles
Yes,
are
ma'am.
same by CPCT. Corresponding part of the congruent triangle are equal with each other. Now we will be saying that, now we are gonna say that we are having two random line. Okay, two random line. We don't know whether those are parallel or what. We don't know. Two just very random line we are having. There is a transversal. There is a transversal, and this green angle and that green angle are called. These two green angle are called. What is the name of this two green angle pair of alternate?
Alternate interior angles.
Exactly. Alternate interior angle. Okay, we are having two such lines and there is a transversal and we are having alternate interior angle, but here alternate interior angle are same. See, in lines and angles chapter, whenever I take the class, I always explain that you are having two lines, whether those are parallel or not, you don't know. Two L and M, two lines you are having, and there is a transversal. Okay, and if this angle is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this one is 7, and this one is 8. Here angle 3 and angle 5, these two are pair of alternate interior angle. These two are same or not, we don't know. The name is alternate interior angle. Yeah, when the line will be parallel, then it will be same. Okay, angle 3 and angle 5 are pair of alternate interior angle. Now, this is the name of this angle. Okay, now when L is parallel to M, then this two angle will be same. When L is not parallel to M, then this alternate interior angle will not be same. So don't just get confused that when I am saying alternate interior, it has to be same. No, the name of this two pair of angle is alternate interior. Now it will be same when the lines are parallel. It will not be same when the lines are not parallel. Okay, from here we can also conclude that when the angles are same, that means lines has to be parallel. When the angles are not same, that means the lines are not parallel. Getting it?
Yeah,
And
yes,
same for the other
Yes, ma'am.
angles also.
Yes, ma'am.
Okay, same for the other angles also. Okay, similarly here angle 2 and angle 8 are, the name is alternate interior angle. Now it depends whether the line are parallel or not, then only it will be equal or not equal. The name is still alternate interior angle. So if any random line, if anyone will draw and a transversal like this, you don't know whether this line P and this line Q, these two are parallel or not, you don't know. But random lines we are having P and Q, and there is a transversal we are having. Let's say the name of this transversal is L. Okay, and we will be calling this angle and this angle. What is the name of this two angle?
Alternately interior angle.
Alternate interior angle. Okay, now we will check if these two are same, then of course P and Q has to be parallel. If these two angles are same, then definitely P and Q must be parallel with each other. Okay, and that's what we are going to say now. And that's what we are going to say now. That's how we will be explaining. That's how we'll be writing over here. That we know that there are two lines. There are two lines, AC and BD, and AB is transversal, such that these two green angles are same. Name is angle MAC is equals to angle MBD. Okay, I'm copy pasting from here. Angle MAC is equals to MBD, and we are realizing, but these two angles name is alternate. This two angles name is alternate interior angle, and these two are same. Then we can say that AC and BD must be parallel with each other. These two are, here we will write, these two are alternate interior angle. Therefore AC and BD must be parallel with each other. Are you getting it, everyone?
Yes, ma'am.
Yes, ma'am.
yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, and AC and BD are equal with parallel with each other. Then from here, what is the motto? What is the purpose? The purpose is still to prove this angle DBC, this angle as a 90 degree we have to prove. Okay, and now we will be proving it. How? Tejas,
Yes, ma'am.
how will be proving this as a 90 degree?
Ma'am, we'll take angle ACB plus angle DBC is equal to 180.
Why 180?
Ma'am, because there's some alternate interior angle sum is 180.
Alternate interior angle sum is not 180.
Ma'am, angles in property.
No.
No, ma'am. Can I say, ma'am? It's the angles formed. It's interior angles formed on the same side of transversal.
Exactly, it's interior angle on the same side of transversal. Okay, we are having two parallel lines. We are having two parallel lines. We have proved that these two lines are parallel. Okay, it was not given in the question. We proved it. Now we are saying two parallel lines, and there is a transversal. And there is a transversal. Then interior angle on the same side of transversal. Interior angle on the same side of transversal. That sum has to be 180 degrees. Interior angle on the same side of transversal. Another name is co-interior angle, which Tejas was about to say, then started saying alternate interior. Co-interior. Co-interior. That means interior angle on the same side. When you are having two parallel lines, when there is a transversal, then on the same side of transversal, whatever interior angle you are having, or inside, the inside part angle, here the sum of this two angle, if this is x, this is y, the sum of this two angle will always be 180 degree, always. Okay, interior angle on the same side sum has to be 180 degree when line L and M are parallel with each other. Getting it?
Yes, ma'am.
Similarly, the other, if this is angle P and this is angle Q, similarly P and Q has to be 180 degree. Why? When L and M are parallel lines. So again, I'll be writing over here. When L is parallel to M, then interior angle on same side sum is 180, or we say it's supplementary with each other. That means sum will be 180. Okay, when L is not parallel to M, it is like, let me write it in a statement, it is not parallel with M, then still we will be calling it interior angle on the same side. Okay, interior angle, focus on the name interior, it's coming in the inside part. Angle, of course, on the same side of transversal. Yeah, still we will be calling this x and y as an interior angle on the same side, but that time sum will not be 180 degree. Getting it?
Yes.
Yes.
Okay.
Yes, ma'am.
So we will
Yes,
be
ma'am.
using this concept over here, that we understand. We understand that AC and BD are parallel with each other. We know that. We have proved it. Okay. And hence we are going to say AC and BD are parallel with each other, and which one we are taking as a transversal, we need to mention over here. So BC, this BC we are going to take as a transversal, and BC is transversal. BC is transversal. Okay, BC is transversal, and therefore sum of this angle and that angle will be giving the proper name. What will be the name? Angle DBC plus what? Who will say? This is B.
AC.
ACB.
This angle.
Exactly. ACB is already given that it is 90 degree. We'll be substituting 90 degree over here. We will be able to prove that ACB is also 90 degree. Yes or no?
Yes, ma'am.
So far, anyone having any confusion?
No, ma'am.
No,
No.
ma'am.
Ma'am.
No, ma'am.
Okay. Now the third part and the fourth part we'll have to. Let me draw the figure over here and let's do the third and fourth one. Yeah. The third part is
part is angle DBC congruent to angle ACB.
we have already proved two parts. Okay, the parts which we have already proved, I am writing over here. Maybe when a particular question is having 3-4 parts, that means you are supposed to use whatever you have proved earlier in the first part, or maybe in the second part, or maybe in the third part. You are supposed to use that. Okay, so let's see what is given over here. We have already proved that these two triangles are congruent. Triangle AMC is congruent with triangle BMD. This we have already done in the first one. And in the second part, just now only we proved that angle DBC is right angle. Okay, now let's do the third part. Why I have written the proof of the first and like what was there in the first, what was there in the second? Because maybe we need to use those information, okay, which we are already having in hand. So triangle DBC, we can focus, we need to focus on this triangle, this DBC, okay, this DBC, and triangle ACB. You can see ACB over here. These two triangles are congruent with each other. That's what we have to prove. Okay, we know one thing is crystal clear. We know that here we are having 90 degree. Just now we proved, and there we were having already 90 degree. That we can use, right? Right?
Yes, ma'am, we can use.
Yes,
What else we can use? What else? This orange color triangle and the purple color triangle we have to focus on.
Ma'am, DB
What?
and AC is by CPCT. DB is
DBC.
equal to AC by CPCT. Yes, CPCT.
This one we have written. You are saying DB is equals to AC. Let's check it. DB is equals to AC. Yes, we can write it by CPCT. In this triangle, DB side is equals to in that triangle AB AC side. Yeah, by CPCT.
Yes. So
Since here we can write triangle AMC is congruent with triangle BMD. From here only we are writing this CPCT. Getting it?
yes, ma'am. And BC has common sides.
And this is the common.
So this is by SAS.
Yes. Okay. So
Yes.
let's check which congruency criteria is working over here. So we have used this angle. This 90 degree we have used this angle. This side we are saying this is a common side. And what else we have used? This side we have used. So SAS, it's clearly visible. Let's mark it over here that by side angle side congruency, DBC is congruent with AC by side angle. So far, any confusion?
No, ma'am.
Okay, now the
No,
last one. Yeah. Irshad, getting it? Farhan.
Yes, ma'am.
Now the
Ma'am,
last part.
CM is equal to halves by AB.
Just a second. CM is equals to half of AB we have to prove. Okay. CM is equals to half of AB. Just now we have proved the congruency of two triangle and the triangle is also visible over here. So can we say these two hypotenuse, that is AB and CD, these two are corresponding part of the congruent triangle? Can we say?
Yes, yes, ma'am. We can say.
We can say that CD is equals to AB. Okay.
And
Why? Because CM AB we have to prove. So obviously we need these two sides. Okay, CD and AB. These two hypotenuses. And from where are we getting? Yeah, please tell me.
we can say M is midpoint.
Yeah, by CPCT. Now
Yes.
only we have proved the congruency. By CPCT we can say that CD and AB, these two side will be same length. Okay.
Yes, ma'am.
Now in the proof part, AB is reflecting. So we are not going to disturb this AB. We will be keeping it as it is. And CD. CD we can break it in like CM plus DM we can write. CD we
Yes,
can
ma'am.
write as a CM plus DM.
Which is
See,
AB.
this is what we want to prove. Okay. Now it is given in the question that CM, DM both are same. If you will recall, it was already given in the question that
Yes, ma'am.
CM, DM both are same. Okay. Here, see, I have written also in the given part, CM, DM both are same. It was given in the question. So we will be saying CM, DM both are same. So let's write at the place of DM, CM. CM plus CM. That is AB. And from here, 2 times CM is equals to AB. And hence CM is half of AB. That's what we wanted to prove. Getting
Yes,
it?
ma'am. Yes, ma'am.
Yes, ma'am.
Everyone getting
Yes,
it?
Yes.
Yes,
Any
ma'am.
confusion?
yes, ma'am.
No, ma'am.
Okay.
No, ma'am.
Okay, so we are done with this much concept. Let's continue. Still we are having the congruency. Just a second. So we are having few like isosceles triangle. What is isosceles triangle? Who will say?
Ma'am, the two
Ma'am,
sides are
two
equal.
sides are same. Two sides are
Yes.
same.
Such a triangle, we are having such triangle where two sides are of equal length. That's called isosceles triangle. What is a scalene
Yes.
triangle?
Where one side, ma'am, where one side is equal. Only
One
like
side equal.
one side.
Scalene triangle.
Yes. And rest of them are not.
Scalene triangle, isosceles triangle, and equilateral triangle. These three categories we are having on the basis of sides. Yes or no? Right? A quick
Yes, ma'am.
overview of this isosceles triangle. Of course, two sides are of same length. If we are having a triangle ABC, if this side is 5 centimeter and this side is also 5 centimeter. Okay, and this can be anything, doesn't matter. If two sides length are same, it's an isosceles triangle. Scalene triangle is a triangle where all the sides are of different length. Yes or no?
Yes, ma'am. And
Yes, ma'am.
equilibrium where all
Better?
are same.
Yes. And equilateral triangle are, here the name is like crystal clear. Equi means equal and lateral means sides. Okay, so equal sides triangle. Do you know that in equilateral triangle each and every angle consists of?
60 degrees. Ma'am.
Exactly, each and every angle has to be 60 degrees if it's a equilateral triangle, because angle sum property says that sum of interior angle has to be 180 degree, and hence since all the sides are same, all the angles will also be same. Now from here
Yes.
I am getting one more theorem which is there related to isosceles triangle. If two sides are same, opposite to those two sides, angle will also be same, right?
Yeah, yes, ma'am. It will be.
So which two angle will be same over here? Angle A, B, C. Like which two will be same with
Ma'am,
each
can
other?
I say
Yeah, sure.
um, A and A and C. No,
A and C. Is it so?
no, ma'am. A and B.
Is it A and B, A and C, C and B? Which two? Who will say?
Ma'am, B and C.
B and C.
Angle opposite to the sides are equal. So A and B will be equal.
A and B will be equal. Okay. Yes, anyone who is remaining? Please let me know what are you thinking.
Ma'am, angle A and angle B will be equal. Opposite angle.
Okay, angle A and angle B will be equal. Okay, let's see which two angle will be equal over here. Okay, we understand this theorem. Okay, we already understand that two angle has to be same. And if I'll give you the isosceles triangle, which most of the time you will be getting in your book, you will be able to tell me. But since I have written the side like here and there, the two like side which I have written same length, that not I have written that way, the way you always get in book. Okay, it can be like this also. This is also isosceles triangle. Opposite to this side, angle A is there, and opposite to this side, angle C is there. This two angle will be equal. Getting it?
Yes,
Yes, ma'am.
yes.
Getting it?
Yes, ma'am.
Angle A and angle C will be equal with each other. Now, what about that isosceles triangle which you get in your book? So suppose this is a isosceles triangle. Here, this side AB and this side AC are equal. Then why we say that B and C are equal? Because opposite to this one, C is there, and opposite to this one, B is there. And from here only one, like if you understand the opposite angle concept, okay, here only in right angle triangle, there is a concept that opposite to 90 degree, whatever side is there, that side is called hypotenuse. Yes or no?
Yes, ma'am.
Yes, ma'am.
So how we take the opposite? This is how we take the opposite. Okay, just opposite to that side. Just opposite to that side. Okay, this is how we will be taking it. So even if in isosceles triangle, any two sides are given same, we will be able to identify which two angle will be same. Yes or no?
Yes, ma'am.
Okay,
Yes,
let's
ma'am.
continue. Now there is a theorem which we like already like always we have used this concept that, let me write the theorem over here first. We'll be proving this theorem and then we will proceed. Angles opposite to equal side of an isosceles triangle are equal. If we are having an isosceles triangle, if we are having an isosceles triangle where the name is written isosceles, so we can take isosceles, that means two sides has to be same. It is given in the question. So we can take that it is given in the question. Given. It is given that AB and AC are same. Okay, it's an isosceles triangle, hence ABAC, two sides we have taken same. We have to prove over here that angle opposite to equal side. Whatever sides are same, no, that side's opposite angle will also be same. That's what we have to prove here. We know it has to be same, and we have used this concept in previous class also. But here we have to prove it by using the concept of congruency, because it's very simple to prove. Who will say what to do over here? A construction we will be doing. Okay, a construction we will be doing which will help us proving it safe. What to do? Any idea? Which type of construction can be done over here?
Ma'am, can we draw a bisector from the angle A?
Yes, angle A bisector we can draw. Angle A bisector. So if this complete is angle A, we can say this much is half of A, half of angle A. And this much is also half of angle bisector we have. Okay, we will write it in the construction part that we are dropping a bisector. We are drawing a AD is bisector of angle BAC. Such a line we have drawn over here. From the vertex A, we have dropped a line AD such that it works like a bisector of angle A. Okay, that means this part of angle A and this part of angle A both are same. Okay, if the complete angle A, if the complete angle A is x, then we can say this is x by 2 and this is also x by 2. We can say that. Okay. Is it possible to prove now? Is it? By concept of congruency, we can see two triangles. Let's try it. Okay. If we don't know what to do, let's move in the direction. Whatever is coming in mind, start writing. So we can see
AB is equal to AC, that is given.
Triangle ABD and triangle ADC. This two triangle is visible over here. Congruency. Just now we are just continuing with the concept of congruency. Let's continue. We will say that ABAC is given same. ABAC given same. Given already.
Ma'am, angle ADB and angle ADC is equal to 90 degree.
So we are drawing a perpendicular and that we are drawing a altitude also, but we have not mentioned over here. This AD line was not given in the question. We are drawing it and we have to be clear that this AD is what? Is it dividing the angle or is it 90 degree angle? What exactly? We can make it 90 degree, no worries. Okay.
AD is equal to AD common.
But let's check whatever information so far we are having in hand. Is it helping us or not? Because already we have done the construction and we are calling it bisector. AD is the bisector of angle A. Bisector of angle A. So since we have written the construction, let's take angle BAD from here is equals to angle CAD from here. Yes or no? According to construction.
Yes, sir.
Yes,
And now only they just said that AD and AD is the common side. Now the question is, three information we have got, but we have to check it. Is there from this 5 congruency criteria, is any criteria is getting, like, are we able to match any criteria? If we won't be able to match, then we are on the wrong track. Okay. 5 rules we are having in hand, 5 congruency criteria we are having in hand. Anyone should match over here. Let's check it. Let's check it. This angle, okay, this side, this is A, the vertex A, okay. And what is the next? This side. Oh yeah, side angle side. Can you see it? Can you see it? Can you see it? Side, included angle, and then side. Everyone can see. So one of the criteria must match. This is just one of the way. One of the student from here who said that 90 degree we can draw. Who said?
We can do that way.
Yes, we can do that way also. We can do that way also. By dropping a 90 degree, that way also we can do. To solve a math problem, there are so many ways and all are acceptable. Okay, you just need to be clear with the concept. That's it. Okay, so that approach which you are saying that we can drop a 90 degree over here, that time you don't have to take maybe bisector and all. Okay, 90 degree will work.
okay.
So now we will say that triangle ABD is congruent with, we must write the proper name. Okay, if I will write here ADC, it is it correct? AB, AC are same.
No, ma'am.
AB, AC are same. It is completely incorrect.
Yes,
Okay, so the name, while writing
it
the
should be
name,
ACD.
yes, we have to be specific with the name. So A, this A,
AC and
C, D. AB and AC are same. Now only we have written angle A over here is equals to angle A over there. Yes, we have written AA at the same in the same sequence. AD over here and AD over there. Yeah, we have maintained that. This is the proper name of this two triangle. Okay, by SAS congruency, these two are congruent. But what we wanted to prove? We wanted to prove this the two angles are same. Yes or no?
We have to prove angle B is equal to angle C.
So now we can say that by CPCT, angle ABD is equals to angle ACD by CPCT. Yes or no?
Yes, ma'am.
Can we say?
And we can even say angle
Yes,
B
ma'am.
is equal to angle C by CPCT.
Yes. That's what I have written here. Can you see, Tejas?
Yes, ma'am. Angle C. Angle B and
Angle
angle C.
B. Yeah. So now we can say this triangle ABC. Triangle ABC is an like isosceles. It was given. We wanted to prove that opposite angles are also same. So now we are done with that. No, nothing we have to write. Okay, we are done with the proof. Let me summarize it. We are having an isosceles triangle. We wanted to prove that opposite side are same. We know, but we want to prove that opposite angle are also same. Okay, the sides which are equal with each other, opposite to those sides, whatever angles are there, those angles will be also equal with each other. Okay, that's what we want to prove. So we have written here, it was given that there is an isosceles triangle. We have written the triangle ABC. In triangle ABC, AB is equals to AC. It is given that. Okay, AB and AC are same. It is given over. Now we are doing one construction. That is, we are dropping a perpendicular AD. Not perpendicular. Here bisector we have dropped. However, perpendicular may also work. Okay. So AD we are dropping and we are saying that this is working like that angle, both are same. This is how we have done the construction, and then we are able to prove congruent. Once we are done with congruent, we can see that angle which we wanted to show same, we are able to do so by CPCT. Is it crystal clear to everyone?
Yes, ma'am.
Yes, ma'am. It's clear.
Yes, ma'am.
Let's move
Yes,
ahead. Now the converse of the same theorem, the converse, that is when the angles are given same, then we'll be proving that sides are same. Okay, the side
Okay.
opposite to equal angles of a triangle are equal. The side opposite to equal angle of triangle are equal, which is just the converse of the previous theorem. Okay, converse means just the opposite, the exact opposite scenario we are having. There it was given that sides are same, angle we prove
Yes,
same.
ma'am.
Here it is given that angles are same, sides will be proving same. Okay, let's do it. Let's take a triangle ABC. Let's take any two angle. Let's say any two angle which is given to us, it's same. Maybe we can say angle A and B are equal with each other. Maybe
Yes,
we can
ma'am.
say angle A and C are equal with each other, or maybe we can say the like B and C are equal with each other. So let's take B and C are equal with each other. Okay, angle ABC. However, any two angle can be same. Always you don't have to take B and C. Here I am taking B and C, but any two angle can be same. Okay, ABC and angle ACB, this two angle, we are saying that it is already given in the question. It is already given in the question that these two angle are same. Okay. Now we have to show that side AB and side AC are also equal. How we will be doing so? Who will say?
Ma'am, the angle, this
Ma'am,
side opposite to the angle are same.
No, we have to prove by using the concept of
Here
congruency.
angle B and C are equal. They have the
To prove
same
that,
angle.
AB is equals to AC. We know that when sides are same, opposite angle will be same. When angles are same, opposite side will be same. We know that. But here in the previous theorem, what we did, let me make it clear. We have taken the sides are same, just sides are same. Angle and all, we don't know anything. We don't know anything about the angle. We just know there is a triangle in the previous case. We are having just a triangle where two sides are same. And so far we don't have any idea about the angles and forget about everything. A triangle, two sides are same. Now we have proved here that the opposite angle will also be same by the concept of congruency. With the help of the concept of congruency, we have proved that angle B and C has to be equal. Can you see? But yeah, to prove that we have done a construction by ourselves, but we were able to prove it. Yes or no?
Yes, ma'am.
yes, ma'am.
Now forget about
Yes.
everything. Forget about everything. Isosceles triangle, opposite side, opposite angle. Forget about everything. You are just having a random triangle. Okay, where two angles, the side opposite to equal angle of a triangle are equal. That means equal angle are given, and you have to show that AB and AC, this opposite side will also be same. It has to be same. It doesn't have to be same. We are not going to say that. We will show it over here by using the concept of congruence. Am I making sense to all of you?
Yes, ma'am. You are making.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay,
Yes.
we will be showing
Yes.
here that ABAC will be same. How? By using the concept which we already know. We will check whether the congruency is going to help us or not. Okay. So this time also we will do a construction. Now who will say what construction can be done over AD? Yeah. Yes. In the
Ma'am, we
previous,
can draw a bisector. We can draw a
we can
bisector AB.
just bisector AD. AD is the bisector of angle A, or it is the bisector of side BC.
Ma'am, it's a bisector of angle A.
Okay, so let's draw a bisector of angle A. Okay, that means this part of angle A and that part of angle A has to be same, just like the previous scenario. Uh, without worrying that much, we have taken the bisector. Now we will see, is it possible? Is it possible to prove this two triangle congruent triangle ABD and ACD? Is it possible? So here, quick, we'll be checking. Okay. So this angle, that angle same. This angle, the two marked, this B and C given, it's same. And AD is the common. Is it following any criteria, the congruency criteria? That also we need to be specific. We are having 5 rule in hand. 5 criteria in hand, and from that 5 criteria anyone should match. Okay, so this angle we have used, this angle we have used, and this side we are saying. So which criteria is getting fulfilled over here? AAS, angle,
ASA.
AAS congruency criteria, right?
Yes, ma'am.
Ma'am, is it ASA?
Yeah, it is AAS. Can you see AAS? Because SAA rule is not there. SAA criteria is not there. So AAS criteria we are thinking of. Okay. Yes, it is getting fulfilled. Okay, let's prove it. Basically, angle side criteria means angle, then very next angle, okay, or just an angle, and then side. If we are having a triangle, then angle side criteria means angle, then side. Okay. If we are having a triangle, then angle side means angle. Sorry, this angle, like back to back, both the angles must be there. Okay, this angle, and this side. Are you getting it? What is the meaning of this criteria? Angle
Yes,
side
ma'am.
criteria.
Yes, ma'am.
Back to back,
Yes,
both the angle has to be there. Okay, and then the
Yes,
next
ma'am.
side. Let's just a second. Yeah. So yes, this criteria is getting fulfilled. We will be able to prove these two triangles are congruent with each other. That means triangle ABD will be congruent with triangle ACD. You have to write the information, what are same and everything, the given part also. And then you have to say that yes, these two triangles are congruent, and therefore